Have you ever stopped and wondered how water power works? It's an intriguing question, isn't it? We're talking about a force that has been harnessed for thousands of years, powering ancient civilizations and shaping our world today. Now imagine a future where water power could provide clean, renewable energy for our cities, industries, and homes. Yes, the possibilities are as vast as the oceans themselves. It's not magic, but the science behind it is pretty remarkable. Let's dive in and explore what water power, also known as hydropower, really is. Water power, or hydropower, is a form of renewable energy that harnesses the force of flowing or falling water to generate electricity. It's like letting nature do all the heavy lifting. Picture a river cascading down a mountainside. That's not just a beautiful spectacle, it's potential energy in action. But where did this idea come from? Well, the concept of water power is far from new. It dates back to ancient times, with the earliest known water wheels used by the Greeks around 3,000 years ago. These were simple devices, often made of wood, that used the flow of water to turn a wheel, which in turn performed some kind of mechanical work, like grinding grain into flour. As civilizations advanced, so did the uses of water power. In the Middle Ages, water wheels were used in Europe for a variety of tasks, from powering mills to aiding in the production of iron. By the late 19th century, water power had evolved into hydropower, with the first hydroelectric power plant built at Niagara Falls in 1896. That's right, the same force that's been grinding grain for thousands of years is now lighting up our cities. Today, hydropower is a major source of renewable energy worldwide. It accounts for about 16% of global electricity production. That's more than wind and solar power combined. It's even used in some of the world's largest power stations, like the Three Gorges Dam in China, which is the world's largest power station of any kind. So, why is water power so popular? It's because water is a renewable resource, meaning it won't run out, and using it for power doesn't produce harmful emissions like burning fossil fuels does. Plus, it's reliable. Unlike solar and wind power, which depend on the weather, hydropower can generate electricity around the clock, as long as there's a steady source of water. So, water power has been around for a while, but how does it work in modern times? The harnessing of water power has come a long way since the water wheels of old. These days, the process has been refined and optimized, utilizing a system of interconnected components to maximize efficiency. Let's take a closer look at the fascinating mechanics of modern hydropower systems. At the heart of it all, we have four main components: the dam, the reservoir, the turbine, and the generator. Each plays a vital role in converting the natural force of water into usable electricity. Let's start with the dam. The dam, often an impressive feat of engineering itself, serves a crucial role. It restricts the flow of a river or stream, creating a large body of water known as a reservoir. This reservoir acts like a gigantic battery, storing potential energy in the form of water. The next stop on our journey is the turbine. When the stored water is released, it flows down a pipeline, gaining speed and kinetic energy along the way. This forceful flow of water strikes the blades of the turbine, causing it to spin. This movement of the turbine is where the magic happens, the transformation of the water's kinetic energy into mechanical energy. Finally, we reach the generator. As the turbine spins, it drives a shaft connected to a generator. Inside the generator, a magnet spins within a coil of wire, creating a flow of electrons. This flow of electrons is what we commonly refer to as electricity. This process from dam to generator is a testament to human ingenuity. We found a way to harness the natural flow of water, converting it into a form of energy that powers our homes, our cities, and our lives. In essence, the water's kinetic energy is transformed into mechanical energy, then finally into electrical energy. This is the remarkable journey of water power in the modern world, a testament to our ability to harness and utilize the forces of nature. Now that we know the components, let's delve into the science behind this process. To understand how water power works, it's essential to explore some fundamental principles of physics, including potential and kinetic energy, the law of conservation of energy, and the role of gravity. Let's start with potential and kinetic energy. You see, water stored in a reservoir behind a dam has potential energy due to its position above the ground. This is similar to how a ball at the top of a hill has the potential to roll down. When the water is released from the reservoir, it flows down due to gravity, and this potential energy is converted into kinetic energy, the energy of motion. This brings us to our next point, the law of conservation of energy, which states that energy cannot be created or destroyed, only transformed from one form to another. In the case of hydropower, the potential energy of the stored water is transformed into kinetic energy as the water flows down. This kinetic energy is then converted into mechanical energy by the turbines, which is finally converted into electrical energy by the generator. Now you might be wondering, where does gravity come in? Well, gravity plays a crucial role in the whole process. It's the force that pulls the water downwards, causing it to flow from the reservoir through the turbines. Without gravity, the water wouldn't flow, and there would be no kinetic energy to convert into electricity. So, in essence, the science behind water power is a beautiful dance of energy transformation, powered by the force of gravity and guided by the law of conservation of energy. It's a process that's been happening naturally in waterfalls and rapids for millions of years. But through human ingenuity, we've been able to harness this power and use it to generate electricity, power our homes, and fuel our industries. It's the clever application of these principles that allows us to tap into this renewable source of energy. Like any source of energy, water power has its pros and cons. Let's dive into these, starting with the benefits. Firstly, water power, also known as hydropower, is a renewable source of energy. That's right, it's powered by the water cycle, which is driven by the sun. This means that as long as the sun keeps shining and rain keeps falling, we'll have access to water power. Secondly, hydropower produces low emissions. Unlike fossil fuels, which release significant amounts of carbon dioxide when burned, the process of generating electricity from water does not directly emit greenhouse gases. This makes it a cleaner source of energy, contributing less to climate change. A third advantage is the ability of hydropower systems to store energy. Hydroelectric dams can be used like giant batteries. When electricity demand is low, excess electricity can be used to pump water back up into the reservoir. Then, when demand is high, this stored water can be released to generate more electricity. However, despite these benefits, water power is not without its downsides. One of the major challenges is the environmental impact. Building large hydroelectric dams can disrupt local ecosystems, affecting wildlife and even displacing people. Also, dams can prevent fish from migrating, which can have serious implications for local fisheries and biodiversity. Another disadvantage is the need for specific geographic features. Not all locations are suitable for hydropower. You need a sufficient water source and a significant height difference for the water to fall, which is not feasible everywhere. Finally, there's the issue of reliability. While the water cycle is a constant process, water flow can vary with seasons and climate conditions. In times of drought, for example, hydropower production can significantly decrease. It's clear that while water power has its challenges, it also holds significant potential. As we continue to grapple with the impacts of climate change, the pros and cons of all our energy sources need to be weighed carefully, and in the case of water power, the scales may tip in its favor. So, we've taken a deep dive into the world of water power. It's been quite a journey, hasn't it? Now, let's take a moment to recap and make sure we've got everything down. We started by asking, what is water power? We learned that it is the conversion of the energy in flowing or falling water into electricity. This form of energy generation is not a new concept but has been around for centuries, powering mills and machinery long before the advent of electricity. Then we explored modern hydropower systems, which are a far cry from the simple water wheels of the past. These systems harness the energy of water in different ways, from traditional dammed reservoirs creating hydroelectric power, to innovative tidal and wave power systems. We dived into the science behind water power, understanding that it all comes down to the physics of potential and kinetic energy. Water stored at a height has potential energy, which gets converted into kinetic energy as it falls or flows, driving turbines that generate electricity. Finally, we weighed the pros and cons of this energy source. On one hand, it's renewable, clean, and reliable. But on the other hand, it can cause environmental and social disruptions due to the construction of large dams and reservoirs. Next time you see a dam or a reservoir, you'll know the remarkable science and engineering that's at work.